Today we're going to be talking about the absolute value equations and inequalities. So an absolute value is the distance from 0 and it's always positive. The absolute value of x minus b. K means that the distance between x minus b is k. So if you see that we have b here, if we were to move a k distance from b, you can go a k distance in this way, which would be b plus k, or you can go this way, which would be b minus k, which would mean your solution could be b plus k, or it could be b minus k. So let's look at this here. The absolute value of x is equal to 7. We know inside of this x, it could be equal to 7 because the absolute value of 7 is 7, or it could be equal to negative 7 because the absolute value of negative 7 is 7 because we know the absolute value just makes everything positive. So our two answers are x is equal to 7 and negative 7. If we were to graph this on a number line, it would look like this. If 0 was here, negative 7, 7. These are our solutions. Now let's go on to the next one. Consider the equation absolute value of x minus 3. So there's two ways to graph this. Graphically find intersection. So there's two ways to solve for this graphically. We can graph this equation right here and then graph the equation y equals 1. So we're essentially graphing each side of this equal sign separately and then seeing where they intersect. So if I were to graph this, you can see that we're just moving this to the right 3. So our vertex would be here. Our slope is still 1, so we can still just go up 1. And here is the left side of our equation. Now if we were to graph the line y equals 1, that would be right here. Find the x values where they intersect. That would be right here and here. Now let's look at another way to solve for the exact same thing. So what we can do is we can take this 1 and move it over to this side, which would give us y is equal to the absolute value of x minus 3 minus 1. On the other side, now we have 0. So if we were to graph this, we would find our answer wherever the graph crossed the x-axis because y equals 0 is just right here. So if we were to graph this after moving 1 over, we know we would go to the right 3 and we'd go down 1. Our slope is 1, so from there we'd go up 1 over 1, and this would be our graph. Since we set the other side equal to 0, our answer is just going to be where it crosses the x-axis, only the x values. So that would be right here and right here. So our answer for this one, just like the other one, which it makes sense because they're the same problem, is x is equal to 2 or 4. Now we're going to solve for the exact same problem algebraically. So the problem that we were just looking at is the absolute value of x minus 3 is equal to 1. Step 1 of solving this algebraically is get the absolute value by itself. The absolute value is already by itself for this problem. Split into two equations, one equaling positive and one equaling negative. So what this means is we're going to set x minus 3 equal to positive 1 and x minus 3 equal to negative 1. The reason why we can do this is because inside here, we know this could be equal to 1 because the absolute value of 1 is 1, or this could be equal to negative 1 because the absolute value of negative 1 is 1. From here, we can solve. X is equal to 4. X is equal to 2. And you can see that we got the same answer that we did when we did solve for this graphically. Now let's look at this example. We're going to solve for this graphically and algebraically. So what I'm going to do is I'm going to solve for this graphically by moving this 1 over here. So if I were to do that, we have x absolute value of x plus 2 minus 3 is equal to 1. I'm going to subtract 1 to both sides and get the absolute value of x plus 2 minus 4 is equal to 0. which means I move this to the left 2, down 4. Our slope is 1 because there's no number out here. And this is going to be our answer. So our answer is going to be x is equal to, we can see it crosses the x-axis at 2 and 1, 2, 3, 4, 5, 6, -6. Now we can solve for the same thing algebraically. What we need to do first is isolate the absolute value. So right now we have absolute value of x plus 2 minus 3 is equal to 1. We need to get the absolute value by itself, and so we are going to add 3 to both sides. And get absolute value of x plus 2 is equal to 4. That's a really important step and a step a lot of people forget, so make sure that you do this. You need to isolate the absolute value. Once we have this, we can set this equal to the positive 4 and x plus 2 equal to -4. Subtract 2 to both sides. X is equal to 2. Subtract 2 to both sides. X is equal to -6. But you can see these two answers are the same. For the purposes of trying this problem another way, I'm going to use the other method of solving this graphically. I'm going to graph this part of the equation, and then I'm going to graph this part of the equation. So this part of the equation, you know you're moving it to the left 4. There's our vertex. And then we're going to have a slope of 2. So we go up 2 over 1, up 2 over 1. And here is our absolute value function. I'll make this a little bit longer. Next, I'm going to graph the line y equals 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to be this line right here. And you can see that these two lines intersect here and here. This is at x equals 1, and this is at x equals -9. So that is going to be our two answers, x equals 1 and -9. Now let's solve for this algebraically. We have 2 absolute value of x plus 4 is equal to 10. We need to isolate the absolute value by dividing both sides by 2. We get absolute value of x plus 4 is equal to 5. We're going to set this equal to positive 5 and -5. So x plus 4 is equal to 5, and x plus 4 is equal to -5. Subtract 4 to both sides. X is equal to 1. Subtract 4 to both sides. X is equal to -9. And these are our answers. Now let's try the next example. Solve the absolute value equation algebraically. So we have the absolute value of 6x plus 5 is equal to 13. Step 1, isolate the absolute value. It's already done. So now we can just set this equal to positive 13 and -13. A mistake I see a lot of people making, which I don't want to see any of you make, is instead of changing the positive 13 and -13, they'll change the 6x plus 5 and the 6x plus 5 to a 6x minus 5. That is incorrect. You must change this number at the end. From here, we subtract 5 to both sides. We get 6x is equal to 8. Divide both sides by 6. X is going to be equal to 8 over 6 is the same thing as 4 over 3. On this one, we subtract 5 to both sides. 6x is equal to -18. Divide both sides by 6, and x is equal to -3. And these are our answers. Now let's look at the next problem. Solve the absolute value equation. We're going to solve for this graphically and algebraically. So I'm going to graph both sides of this equation. We have an absolute value of x plus 7. So 1, 2, 3, 4, 5, 6, 7. It has a slope of 1. So this is going to be our absolute value. Now I'm going to graph y equals negative 2. But wait, we have a problem. These two things do not intersect. For this problem, the answer is no solution. The reason why this is no solution is because we have an absolute value equal to a negative number. Anything that's an absolute value cannot be negative because the whole point of absolute value is whatever you have, you make it positive, which means that this is unsolvable. Okay? The one thing that I need everybody to make sure that they do is before they determine something to be unsolvable, they must isolate the absolute value function. So now if we were to solve for this algebraically, we have absolute value of x plus 7 is equal to negative 2. And there's just nothing we can do because you can't set this equal to the positive and negative version of this because it's already a negative number. If you were to do this, this would be incorrect. That is a mistake people make all the time. So if you see a negative number like this, it does not work. And I will show you. Say I didn't know and I set this equal to positive 2 and negative 2. I'd subtract 7 to both sides and get x is equal to negative 5. And I'd subtract 7 to both sides and I would get x is equal to negative 9. If I were to put this number back in here, this would get me positive 2, which is not equal to negative 2. Doesn't work. If I were to put this number back in here, I would get negative 2, which brings me to positive 2. Also would not work. Does not exist. Don't get confused with these types of problems. So now notice, when c is less than 0, there is no solution to the absolute value equation. Now, there could be cases where you have an extraneous solution, which means an apparent solution that is rejected. You are going to get an extraneous solution when you have an absolute value equal to something with an x. So before this problem, we've dealt with absolute values equal to numbers, but right now we have an absolute value equal to something with an x. When this happens, you are going to have an extraneous solution. So let's take a look at this problem. We already have the absolute value isolated, so we can set this equal to 3x minus 24 is equal to 5x, and 3x minus 24 is equal to negative 5x. If we were to solve for this, we would get 2x equals negative 24. Divide both sides by 2. X is equal to negative 12. If we were to solve for this one, we would get 8x equals 24. Divide both sides by 8. And x is equal to 3. Now, if I were to put this number back in here, I would see that it's not going to work. Because if I were to put negative 12 in for this x, this would give me negative 60. And like we just talked about before, an absolute value can never equal a negative number. If I were to put this negative 12 in here, we would get negative 36 minus 24, which would be negative 60. But the absolute value of negative 60 is positive 60. Positive 60 does not equal negative 60, so this is not going to work. If I were to put 3 in here, we get 9 minus 24. 9 minus 24 is 15. If I were to put 3 in here, we would also get 15. So this is our only answer. I want you all to flip to the next page. And I want you to look at the solving absolute value equations practice. I want you to have this completed by next class. Bring the rest of your notes to class with you the next time I see you, and we will finish the notes in class.